Hello there. Really quickly, I want to start a video series on solving polynomial equations. So I'm going to start very basic and work my way up. So this is pretty straightforward. We have a difference of two squares. I'm going to go ahead and start by adding 4 to both sides. I get x squared equals 4. Then I take the square root. And of course, when we do this, we have to consider the positive and negative solution. Now, the other way to solve this is with the difference of squares formula. That'd be a minus b times a plus b. So we get x minus 2 times x plus 2 equals 0. And then we can use the zero product property to set them each equal to 0. We get x equals 2, and then x plus 2 equals 0. We get x equals negative 2. The way you want to solve it is up to you, but there are two ways to solve the exact
Hello
same
there.
problem. In this video, I really want to quickly solve this polynomial equation. Now, of course, we can start by adding 6 to both sides. And we get x squared equals 6, and then I'm going to take the square root. Now, 6 does not have a nice square root that we can take, so I'm going to leave it as plus or minus the square root of 6. Now, we could use the difference of squares formula to set it up. We would just have to know that 6 isn't a perfect square, so when we set it up, it's x minus square root of 6 and x plus square root of 6. We don't have to have perfect squares to get the answer out of the difference of squares formula. So we'd set these equal to 0 with the zero product property, and then we would add root 6 to both sides. I get x equals square root of 6, and then over here I would get x equals negative square root of 6. I wanted to show you that to you as a little extra flavor on the difference of squares take. Hello there. Really quickly, I want to solve this quadratic equation. This is a tailor-made quadratic that is good for greatest common factor. We're going to look for the greatest common factor of 9 and 24. Since we do not have a constant term, we can do this. So that would be 3. And then the greatest common factor out of x squared and x would just be x. So I write 3x, and now we reduce our factors. 3x squared would just be left with 3x, plus 24x would just be left with 8. And then we can use the zero product rule. 3x equals 0. Of course, this just means x equals 0. And then 3x plus 8 equals 0. We subtract the 8. We get 3x equals negative 8. And then x equals negative 8 over 3. Mainly look to use this rule when we do not have a constant term. We have a quadratic term and a linear term only. Hello there. In this video, really quickly, I want to show you how to solve a basic trinomial quadratic. We're going to use it called diamond math technique. I'm going to put this negative 4 in the top, and I'm going to put the negative 3 down below. Now, I want two numbers that multiply to give me negative 4 and add to give me negative 3. We can cycle through the factors of negative 4, and we'll find that we want one negative and one positive, and the answer would be negative 4 and 1. When we set this up, x minus 4 can equal 0. I'm just skipping straight ahead to using the zero product rule. And x plus 1 equals 0. Then I see my final answers are x equals 4 and x equals negative 1. Look to use this technique when your lead coefficient is 1 and 1 only. If it isn't, there are other techniques that I'll go over in the future. But for now, I'm just going to leave you with that. Hello there. In this video, I'm going to go over another diamond math technique for solving a trinomial quadratic. We need this coefficient to be 1 to be able to do this, but luckily we have a common factor of 4 in all these terms. And if I take 0 and divide it by 4, I just get 0. So I'm going to do that. Divide out 4, I get x squared plus 3x minus 4 equals 0. Now I can set up my diamond math. Negative 4 will go up top, and a positive 3 will go down below. I want two numbers that add to give me negative 4. Multiply to give me negative 4, add to get 3. So that'd be positive 4 and negative 1. X plus 4 equals 0. Of course, that'll give me x equals negative 4. And x minus 1 equals 0. So my final solution is x equals 1. Hello there. We're going to go over another diamond math technique for a trinomial quadratic. Now, in this case, we do not have a common factor that can come out of each term, so we're going to have to do something else. I'm going to take 8 and multiply the 1. And I am changing the quadratic to be something different. But this is okay because it'll allow me to use the diamond math. Okay. And then negative 4 and positive 2 would be my two factors. Multiply to give me negative 8, add to give me negative 2. So x minus 4 equals 0. X plus 2 equals 0. Now, how you do the rest of this is really up to you. I'm going to really quickly solve that x equals 4, and x equals -2. But remember, I started by multiplying that 8. So this would be the solutions to this quadratic, not the original. So I'm going to divide both of them by 8, and I get x equals 1/2, and x is equal to -1/4, and we're done. Hello there. I'm really going to quickly talk about this problem solving a quadratic trinomial. Now you can try the diamond math approach if you want, but you'll find it's not factorable by that technique. So I'm going to use completing the square. I'm going to add 1 to both sides. X squared minus x equals 1. Now I'm going to go ahead and take this 1 here and cut it in half. So 1 divided by 2 is just 1/2. And then I'm going to square it. So I get 1/4, and I'm going to add 1/4 to both sides. And I'm going to simplify. Next thing I'm going to do is I'm going to go ahead and factor this left side. Now, because we took this value and cut it in half and then squared it, that would make x minus 1/2 my factored. And now this leaves me an algebraic approach to square root both sides. I get x minus 1/2 equals plus or minus √5/2. And then we got the golden ratio as a solution to this quadratic. Hello there. Let's go ahead and solve this quadratic trinomial by using completing the square. Now the first thing I notice is that they each have a common factor of 2. And that'll be handy because completing the square works best when you have a lead coefficient of 1. So we get the next step would be to subtract 3 from both sides, -2.5 to get -1, and then square it to get a +1. So I will add 1 to both sides. Next, I'm going to go ahead and factor this. Now this ends up being a perfect square, hence the name completing the square. That's x minus 1 squared equals -2. The final few steps, I'm going to go ahead and take the square root of both sides. I get x minus 1 equals, this will be I times the square root of 2, plus or minus, of course, and then we add 1 to both sides, and we get 1 plus or minus I root 2. Okay, so let's go ahead and do another completing the square problem. I'm going to start by dividing by the lead coefficient. Okay, so what I also did was I took the 3 divided by 3, which is 1, and then added it to the other side. Now, half of 1/3 will be 1/6, and then square it, that'll be 1/36, okay? So plus 1/36 to both sides. I get x squared, or sorry, no, I want to factor now. So I get x minus 1/6. The number that we squared is the number that will go into that perfect square. And I get 37/36. Square root both sides, I get x minus 1/6 equals plus or minus. 37 does not have a square root. It is a prime number, but 36 does. That's 6. And then we add 1/6 to both sides. I get 1 plus or minus √37 with a common denominator of 6. And hello there. In this video, really quickly, I'm going to derive the quadratic formula. I have my steps right here in front of me. So the first thing I'm going to do is subtract c from both sides. All right, the next step, I'm going to divide by a. Now this could have been my first step, but I decided to make my second step. Okay, the next thing I'm going to do is I'm going to complete the square by dividing b over a by 2. That would be b over 2a, and then squaring it and adding it to both sides. Okay, now I'm going to go ahead and I'm going to factor left and simplify right. Now by simplifying on the right, I'm going to have to find a common denominator, which would be 4a squared. All right, and you notice when I simplified the right side, I rearranged the terms as well. The next thing I do is take the square root of both sides. And then finally, we're going to finish it off by subtracting b over 2a from both sides. And there you have it. I combined the numerators to have one singular denominator so it can be written in its traditional form. Hello there. Let's go ahead and solve this quadratic equation by using the quadratic formula. So first we need to identify a, which is 4, b, which is -2, and c, which is 3, and then we're going to go ahead and plug these into the quadratic formula. So that's -2 plus and from here on out, it's just some calculations. -2 squared is 4 over -4. 4 times 4 is 16 times 3 is 48. 4 minus 3 would be -44, and then -44. Now -44 means I'm going to get a I out of the square root, and then 44, √44 is equal to 2√11. You can go ahead and check that. So 2√11 over 8, and then simplifying, that becomes 4, that becomes 1, that becomes 1. Our final answer is 1 plus or minus I root 11 over 4, and we're done. Hello there. In this video, really quickly, I want to go over using the quadratic formula for some missing values. And what I mean by that is notice that A is equal to 1, B is equal to 0, and C equals -4. Now, you could use difference of squares or just simple algebra to solve this, but what fun would that be? So let's go ahead and set it up in the quadratic formula. So that's x equals -0 plus or minus the square root of 0 squared minus 4 times 1 times -4 all over 2 times 1. Okay, now let's go ahead and this will cancel, and this becomes positive 16. So you get plus or minus root 16 over 2, which is plus or minus 4 over 2, which is plus or minus 2, which is what you would expect to get. Hello there. In this video, I want to go over another quadratic formula where we now have a missing C value. So notice A is 9, B is 24, and C is 0. So when we set this up, it's going to be x equals -4 plus square root minus 4 times 0. Now when we're simplifying this, because C is 0, this term just cancels out. And then when we do that, the square root of 24 squared, well, the square and the square root just cancel each other out. So we get equal to -24 plus or minus 24 all over, and 2 times 9 is 18. So really quickly, -24 plus 24 is 0, and that'll be divided by 18, which is 0. We get -24 minus 24, which is -48 over 18. And simplify that. They both have a 6 in common. So that would be -8 over 3, and those are our two solutions. Hello there. In this video, really quickly, I want to talk about what to do when you come across a sum of squares. Now, the first instinct you could do is subtract 1, you get x squared equals -1, and then take the square root. And of course, if you're familiar with complex numbers, this is where you say x is equal to plus or minus I. So you could solve it just like you would a difference of squares. Now, there is a sum of squares factorization for this, but not in the real numbers. In the complex numbers, the sum of squares would just be x plus I times x minus I equals 0. And setting them each equal to 0, we get x equals -I, and x minus I equals 0 gives us x equals I. Now, the final thing you could do is set up the quadratic formula. I'll just set that up, but I won't solve. That would be with A is equal to 1, B is equal to 0, and C is equal to +1. And if you follow through with it, you'll get plus or minus I again. Hello there. Really quickly, I want to give a different flavor on the sum of squares approach. Once again, we could start by solving this algebraically. That is always convenient when we don't have a b term, so we get 2x squared is equal to -6. Now we'll divide by 2. We get x squared is equal to -3, and when we take the square root, 3 does not have a perfect square, so it is not a perfect square, pardon me. So we get plus or minus the I, and we'll just leave it as square root of 3. Now, if you wanted to do this as a sum of squares, it would look a little weird. It'd be square root of 2x plus I root 3, and then square root of 2x minus I root 3. I doubt anybody would want to go through that torture right there. Or sorry, not 3, 6. I'm following the same procedures. Or you could use the quadratic formula with A being equal to 2, B being equal to 0, and C being equal to 6. And that's it.